In this video, we're going to be talking about solutions of systems of linear equations. So hopefully you've already looked at several examples of this in the textbook and in WebAssign. There are three basic options, so let's just review those really quickly. So in general, we're talking about more than one line, and we want ordered pairs that fall on all of the lines simultaneously. So there are three possible outcomes here. One is that you might not have any solutions. And this will happen, for example, when you have parallel lines, right? If these lines never cross, then that means there are no ordered pairs that are on both of these lines. Okay, the most common answer to a problem like this is to just have one solution. For example, say you have, this is line number 1, and then this is line number 2, and this ordered pair will be the solution to the system because it's on both this line and it's on this line. Right, because we want ordered pairs that satisfy both equations simultaneously. So you could have no solutions. You could have one solution where the lines just intersect, but then you can also have infinitely many solutions. And essentially what happens here is you have a line, and then the second equation is really the exact same line, just written differently. Okay, so these two lines are sort of sitting exactly on top of each other, in which case any ordered pair on either line will be on both lines because they're really the same one, right? So there are infinitely many points along this line. So hopefully you've already looked at several examples of the one solution variety, so I want to show you what it looks like if you have no solutions or if you have infinitely many. So let's go ahead and work this example. Solve the system or state that there's no solution. And we're going to be solving this using the elimination method discussed in the textbook. So that means we want to try and multiply either the top equation or the bottom equation by something to make the x terms equal number but opposite value. So for example, like positive 4 and negative 4 would work, positive 8 and negative 8 would work, or any number really, as long as one is positive and one is negative, but their absolute values are the same. And we want to do that for either x or for y. Eventually we'll need to do it for both. So for example, we can multiply this top equation by negative 2. So we're going to multiply, that's what this little dot is indicating, by negative 2, and that's going to give us the new system. So negative 2 times 4x plus negative 2 times 3y equals negative 2 times 4, and then we haven't done anything to this bottom equation. And here I'm trying to sort of space these out to keep them roughly lined up. So remember, when you multiply one of these equations, you do it to literally every term in the equation. Okay, and sometimes students forget to do it on the right-hand side of the equal sign, so be careful. You're also supposed to multiply what's on the right-hand side. Okay, and that's going to give us, the first equation will now be negative 8x minus 6y equals negative 8, to go with 8x plus 6y equals 18. By the way, I chose this negative 2 because I was just looking at the x's. Here I've got 8, so if I multiply 4 by negative 2, it will turn into negative 8, which is good because we want to eliminate one of our variables, either the x's or the y's. But what you might notice is, in fact, this eliminated both the x's and the y's. Right? Now we've got negative 8x to go with positive 8x, but we've also got negative 6y to go with positive 6y. So let's see what's going to happen here. So the next step, after you get one of your variables to match, I mean, it so happens that both of ours match up, you're going to add these two equations together, just term by term. So negative 8x and 8x, that's 0. Negative 6y and positive 6y, that's also 0. Negative 8 and 18, that's 10. So we get the resulting equation, 0 equals 10. Now, is that ever going to be true? Right? This doesn't make any sense. So if you get an equation like this, where you get 0 when you add up your x's and your y's, but you don't have 0 on the right, that means that there's no solution, right? This doesn't make any sense. So if you get to the point where you've eliminated a variable and then what eliminates one variable simultaneously eliminates the other variable, that means you're in the situation where you either have no solution or infinitely many solutions. Now in this case, because we had 0 equals 10, that doesn't make any sense, so we got no solution. But if instead this had been negative 18 to go with positive 18, and we had gotten 0 equals 0, that would mean that there were infinitely many solutions, and that really we had two copies of the same line in these equations rather than different ones. So no solution, that means that these lines are parallel. And in fact, if you wanted to think about the slopes of these two lines, so we learned earlier in the chapter how to calculate slope for these two lines. And if you look at the slope of either of these, it's going to end up being negative 4/3 is the slope for both of these. You can verify that if you'd like. So these are going to be parallel or the same. And remember, that's parallel lines corresponds to no solutions. The same line corresponds to infinitely many solutions. So anytime you try to eliminate one of your variables and both variables disappear, that means you either have no solution or infinitely many, and that's only going to depend on what you get down here. If you get 0 equals 0, that means infinitely many solutions. If you get 0 equals literally anything other than 0, that means there's going to be no solution.